Yeah.
Good morning to one and all. Now I request to our Pro Vice Chancellor and Director of School of Earth Sciences, Dr. Devendra Mishra sir, to introduce today's guest, resource person, and give the introductory speech on this wetland International Wetland Day. On the occasion of this, the International Wetland Day, the Wetland Systems. So I request to Dr. Mishra sir to give the introductory speech.
A very good morning to all of you. Namaskar. I must congratulate to all the 1614 participants from 23 countries on this World Wetland Day celebration by Punyaslok Ahilya Devi Holkar University, Solapur, where we have organized this special online lecture come webinar of Dr. Alexandros Stipnakis, and I welcome everybody, including our Honorable Vice Chancellor Madam, Dr. Fadnavis, all the organizing committee members, and fellow friends. Wetland systems, everybody knows, that is unique and it is naturally created, which has many diverse functions, and it shows the real existence of ecosystems because it has a diverse range of microbes, plants, and animals staying in harmony in such systems. In fact, in this world or in the earth, we have only 1% potable water, even if 2.5% water is fresh, but out of that, only 1% is available for human consumption in a proper form, and most of it are stored in wetland systems. Wetland system has three specific characteristics, and wetlands are transitional zones between terrestrial and aquatic systems. Because of this, a group of organisms came into existence, evolved, called as amphibians. They could live in both the systems. And today, wetland systems have become very significant for the survivability of not only human race, but almost all the animals. Therefore, it has become a world concern. Fortunately, India is one of the few countries in the world which has wetland inventory system, wherein the remote sensing techniques have been used. And in India, 42 sites are located as international important wetland systems. Every human being is fascinated and attracted towards wetlands. Peace of mind and appreciation of understanding the nature's ecosystem are certainly received at wetland places. Therefore, large number of tourists are always found at such water bodies all over the world. In the present system, this year, the Wetland Day, that is 2nd February 2021, has focused more on restoring wetlands and saving fresh waters. This is the theme of this year's Wetland Day celebration. Wetland systems are engineered ecosystems that can be used for improving water quality, whether it relates to wastewater, stormwater, groundwater, industrial waste, and or diffuse pollution, and can be implemented in urban, in peri-urban, and in agricultural landscapes. In the modern science, we are developing hybrid wetland systems. We are constructing and structuring wetlands in an engineered manner that can use the natural functions of the vegetations, soil, and organisms to treat the wastewater. It is important for everybody to save this water for our own use, for our own benefits, and the participants, those who have already registered and asked us several questions. I found it is a very important mindset of the people of their concern, the students, researchers, and the participants about the wetland systems. They have asked very wonderful questions, which will be definitely attended and answered by Dr. Alexandros. I wish this webinar or this resource person's delivery a very successful one and satisfying one. I am having the privilege to introduce you the today's very important, very special guest of us, Dr. Alexandros Stefanakis. He is associate assistant professor at the School of Environmental Engineering, Technical University of Crete in Greece. He is also the regional coordinator of Africa and Middle East for the Wetlands for Water Pollution Control, specialist group of the International Water Association. He is the editor-in-chief of the journal Circular Economy and Sustainability. He is an expert in ecological engineering and technology, specializing on the use of nature-based solutions for water and wastewater management. His expertise is the design of constructed wetlands and wastewater treatment and sludge dewatering and reuse. As an environmental engineer, he has designed and built several wastewater treatment facilities using wetland technology in many countries around the world. He has been and is currently involved in more than 15 international research projects in various countries. He holds a record of publications and international scientific journals and conference proceedings, while he has also published 3 books and many chapters on his specialized field. It's a privilege to us and to our university to have such a guest to deliver who has the mastery and has been involved in wetland systems and the ecosystems in particular, and I wish he will be useful to all of our participants. I wish him also best of time. Thank you very much.
Thank you, Professor Mishra, sir. Now I over to Alexandra, sir, to give the address, resource person address to all the participants. I request Alexandra, sir.
Okay, thank you very much. First of all, for the invitation and for the very nice words that you just used to introduce me. So should I share my screen, my presentation?
Yes, sir.
Yes, sir.
So, can you see my screen?
Not yet. Yes.
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 Okay. So, thanks again for this invitation on this the webinar you decided to host today about on this special day for us working in this field. So I will talk about the use of engineered wetlands, as we call them, constructed wetlands, and how we use them in the field of water engineering, and specifically for wastewater treatment and management in a sustainable way. Allow me to say a few words about me and where we are. So, as you said, I come and I'm currently based in Greece. We are in the South Europe, in the Mediterranean basin. This is the countries here, and I'm based in Crete. Crete is the largest island here in the south of Greece, the largest island of Greece in the Mediterranean. And our city is called Chania, as you can see here. And as almost every city in Greece, it is an ancient city and has a history of several thousand years. And this is some pictures, some views of our city and the natural beauties that also have in this island. So our university is almost more than 50 years old and is currently one of the 1 or 2 most prestigious research institutions also in Greece, with the highest output in terms of research output. and hosts several engineering schools. And I am part of the School of Environmental Engineering, where we have different divisions studying different aspects of the environment. And personally, I belong to the second division, where I study and I work on water and wastewater engineering, and particularly on phytoremediation and wetlands technology. So I will say a few words about natural wetlands first. Okay, what is a natural wetland? What is a wetland in nature as we know it? Then I will move to constructed wetlands and describe how we were inspired from natural systems, from natural wetlands, in order to develop this wetland technology that we are currently using for wastewater management. And I will get into more details on wetland systems, the different types, the services, the advantages, and the limitations. And I will show you also several case studies and projects from all over the world. So what is wetland in nature? I think more or less everybody knows this or has a good idea of this. It's the interface, as we say, between terrestrial and aquatic ecosystems. So wetlands in nature will have water either at the surface or within the root zone, the rhizosphere, as we say, for at least a part of the year, if not throughout the year. So wetlands have a unique waterlogged soil conditions that differ them from the adjacent uplands area. So it has, where is lower oxygen. And in this way, wetlands would support plants, specific plant species that are adapted to these wet conditions. And these plant species, we call them hydrophytes. And wetlands in nature are one of the most productive ecosystems on the planet, and they have a very high capacity to transform and store organic matter and nutrients. And this is one of the main characteristics that we observe in natural wetlands. And that's why they are often characterized, the natural wetland systems, as the Earth kidneys. Why is that? Because they operate as the filter. So as the kidneys in our body are practically the filter units to filter all the water or the fluids that we take, this is the same, the main service of wetland systems in the planet ecosystem. So they filter water, they retain pollutants from the water that flows through them on its way to reach the lakes, the streams, and the oceans. So this is the main process, the main capacity of natural wetlands that some scientists observed and monitored many decades ago. And this is how the idea was born that we can take these processes that naturally occur and exploit them for our purpose, which is water treatment, but in this case under a controlled environment. So engineers apply these natural cleaning capabilities of constructed wetlands and exploit and enhance them for our benefit. And of course, the wetland system is a combination, as a result of this, combination of the modern industrialized society and the natural environment. So this exactly was the reason and where the transition from natural to constructed wetlands was based. So the humans make constructed wetlands, we build constructed wetlands in areas where such systems did not exist before. And in a way to mimic the natural processes that occur in natural systems. And the whole technology, the eco-technology of constructed wetlands belongs to a wider category that we call nature-based solutions for water management. And what is the idea here? The idea is that we take concepts from nature and we bring them into cities or into the environment where we are living. So we design ideas that we inspired or derived from nature. And what are the services that this type of systems and eco-technology can offer? Of course, the first and the most important one is water purification, but also runoff and flood control, nutrient recovery, retention of heavy metals and recovery of nutrients and other valuable constituents, They offer a broad range of bio and plant-based materials. They contribute to climate change mitigation and adaptation, while they also regulate the microclimate in the area where they are installed. So overall, we can say that they have an environmentally friendly character, and they are mostly, in general, characterized by a reduced carbon footprint. Don't use any chemical compounds there for the treatment, and of course, they are more acceptable from an aesthetical point of view. We don't use energy, or we use just minimum amounts of energy, and from the financial point of view, the construction can be usually cheaper than the conventional technologies for wastewater management. But the main benefit is during the operation of these facilities, where we have significantly reduced operational costs. So what is nature-based solutions and natural wastewater treatment system? This is an alternative approach to deal with wastewater treatment than the conventional or the mechanical technologies that we all know. And they serve a different approach, which is called the decentralized approach, which some of you may have heard before, to provide an integrated sanitation service. So it is considered a smarter option for wastewater management, with more cost-effective, reduced capital costs, a green and sustainable solution, provides increased opportunities for local stakeholders to participate in the decision-making process. Of course, they offer environmental protection and, most important, protection of the public health. And because of the decentralized approach and design there of the whole wastewater management, we minimize the need to transport or pump wastewater to long distances. So constructed wetlands are designed to mimic the functions of natural wetlands, but under a controlled environment. And in these systems, we have naturally occurring pollutant removal processes, which are mediated by the interactions between the system components. And what are the system components there? So what is a wetland made of? It's the water or wastewater, the substrate media that we are using, so gravel and sand, usually the plants, the microorganisms that also naturally develop and grow in the systems, and of course, the environment, the energy we take from the environment. So we use natural responses, gravity flow, for example, or sedimentation, and natural components to build these systems. So you can see the difference from conventional systems, where we use also synthetic materials, concrete, cement. So these are heavy installations. And the main services, if we can summarize, of wetland technology: wastewater treatment, sludge dewatering as well, flood control, and of course, habitat creation. And this is how a wetland bioreactor, because eventually a wetland system is a bioreactor, this is how it functions. So we have several biological, chemical, and physical processes, pollutant removal and transformation processes, that take place and occur within the wetland body. And because of these different processes, different pollutants that might be present in the wastewater can be removed. So you can see all these pollutants can be effectively removed in a wetland system if, of course, the design of the system is appropriate. And for wetland technology, so we have different types which can be classified depending on mostly on the flow path and the flow characteristics. So we will have a horizontal subsurface flow system where the water level is maintained below the surface, a few centimeters below the surface of a gravel layer. The free water surface flow system, where we have a water column above the soil layer. A vertical flow system, again, we have a gravel bed. The floating treatment wetland, it is a relatively new system where we have floating mats in a water body where the plants are established. And the latest development of wetland technology, which is the aerated wetland, where we use small amounts of air provided by artificial means in order to enhance the aerobic processes within the system. And of course, a very nice application is the application of wetland technology for the watering of sludge, municipal sludge or industrial sludge, but usually municipal sludge that is produced from conventional treatment systems. So as you can see, there is a wide toolbox of wetland types that we can use depending on the application and the source and the composition of the wastewater that we can use to treat, in each case, this particular wastewater. So if we will summarize the benefits of treatment wetlands and generally of natural treatment systems compared to a mechanical technology. This would be a nice summary of the benefit, the advantages in comparison. So the main limitation will be that a wetland system would always have a higher area demand compared to a mechanical technology. Since we are talking about the natural processes, these processes are always slower, so we will need more land. But in terms of costing, to build such facilities, the cost will be more or less the same, and especially if the land is available, it can be even cheaper. But the advantages are from the operational phase, so we have significantly lower cost, minimum demand for energy input, long life expectancy. We don't need usually specialized staff to run the facility. We can design the system even with integrated sludge dewatering and sludge management. And if the system is properly designed and constructed, we can avoid issues such as moths or mosquitoes that could be present in mechanical technologies. And of course, the whole design, the whole system, the whole nature of the system is an environmentally friendly and has an ecological character. So to summarize the advantages, as you can see here, low investment, long lifespan, low energy input. We don't use chemicals. There is no byproduct from the operation of these facilities. And of course, it's also important when we apply them for industries because they improve the green profile and they could be integrated in the corporate social responsibility activities of the industries. And in terms of application, we have systems now that are applied even in the desert, so under very hot and arid climate, or even under cold climates, as you can see here. And the effect of the temperature practically would be reflected in the sizing of the system. So we have now developed advanced design approaches to design wetland systems so that we can produce more accurate designs and calculate with very good accuracy the required surface area, where also in the design the temperature effect is considered. So now I will show you different projects and case studies from all over the world, from hot and warmer and arid areas. So one of the most interesting application is the wetland system, which are designed for stormwater management. So what we do here is that we receive the stormwater, the runoff from the urban catchment or the combined sewer overflow, and instead of drive it through the conventional wastewater treatment plant, we will drive it through a stormwater retention pond and constructed wetland before it reaches the receiving body. Could be a river, could be a lake, could be the sea. So in this way, we can reduce the runoff volumes that pass through a conventional wastewater treatment plant. In this way, we can minimize first the capacity and the sizing of these facilities. We can reduce the risks which are associated with combined sewer overflow wherever this exists, protect the downstream water resources, we reduce the risk of flooding, improve the water quality. We can even use, and there are many cases where we use the effluent to recharge the groundwaters, to increase the runoff infiltration, and of course to stabilize the sediments, and we create a new wildlife habitat and provide recreation activities as well. These are some systems, some on full-scale and operating systems. So this is a runoff stormwater wetland in Germany, which receives and treats combined sewage overflow. This is a system built in Australia, which collects and treats stormwater. And as you can see, it is installed within the residential area. So these are some nice examples. Another system for stormwater management from the US in Phoenix. So this is a wetland system that is designed and is built to further polish the treated wastewater from the nearby very large conventional treatment plant, and also receives runoff, urban runoff from the nearby town. So it provides flood control, habitat restoration in that area, public outreach. The water is also reused for irrigation after in the effluent, and also it is used to offset the carbon footprint of the whole water management process. Another system for domestic wastewater treatment, this is built in the desert, so in a very hot and arid environment. So there is a settlement here which has a population of 600 people, and we built there a facility with 2 stages, vertical flow constructed wetlands, where we integrated in the first system sludge mineralization and dewatering. So we don't have sludge production on as a byproduct on the daily basis, as would be the case in conventional wastewater treatment plants. So after the treatment in the two stages wetland, the treated effluent is with gravity flow goes to a irrigation field where we have created a small oasis or forest, how you want to call it, on site. So this facility treats 120 cubic meters per day. And the interesting thing here is that we don't use any electricity. So the wastewater comes from tanker trucks. It is discharged here, and only with gravity flow, it passes through the system until the irrigation field. So we don't have any electricity input on this facility. So this is a picture of when the truck comes and discharges the wastewater in the first stage. An aerial view of the 2 stages of the wetland facility, how the system looked just after planting, the first planting of the reeds, of the reed plants, and how it looked after 1 month after planting. And here you can see how sludge is integrated and dried on the long run on the surface of the first stage. So in this way, because of the presence of the reeds and the roots of the reeds, we have this sludge dewatering process, which means that we don't need to have a separate line for sludge handling. And this is important. Why? Because in conventional wastewater treatment methods like activated sludge, membrane bioreactors, sludge is a daily byproduct that needs daily handling. So you will have maybe a filter press or a centrifuge to dewater sludge that is produced there. But this means that these systems are very expensive to install and especially to operate. They have a very high energy input. So there are many cases where just the sludge handling line, the cost to run the sludge handling line represent up to 50%, so half of the overall cost of the wastewater treatment plant. So to have a natural process for sludge dewatering and handling without a separate line, it's really important. And for this facility, how it looks today, so you can see it looks like a wetland, and don't forget we are in the desert. And this is the irrigation field, the small forest that we created there in the desert, and the residents there can even go there and find some rest under the trees. Another design for domestic wastewater treatment is this one, where we use the latest development of the aerated technology. So here we are serving almost 2,000 persons. The first stage of the facility is again a vertical flow system with integrated sludge dewatering, and the second stage is an aerated horizontal subsurface flow constructed wetland. Afterwards, we have disinfection with a UV system, and the effluent is reused in the residential area for irrigation of green spaces. So this system has one of the lowest area demands for wetland technology, approximately 1.5 to 1.6 square meters per person. This is how it looks like during the construction, and this is some pictures of the facility during the first months of operation, the first stage and the second stage. And from the first stage to the second stage, we have gravity flow. So we only have pumps in the upstream to bring the water to the first stage, and downstream to collect the treated effluent to send it for irrigation in the residential area. So if we compare constructed wetlands with the conventional technologies in terms of energy and operational and maintenance needs and area requirements, you will see that in terms of energy and maintenance, we are on the least side. So the natural treatment systems in general have very low demand for energy and operational and maintenance needs, while they will have a higher area demand. But as we developed advanced designs for wetland systems, so intensified wetlands like the vertical flow design or even aerated wetlands, we close somehow this gap, which means that we can even go into areas where space is more limited. So we don't have this high availability of space like in suburban or even in urban areas. Another example for an industrial effluent. So this is a glass manufacturing industry. So it's not very common that we have such industries with wetland systems. This is why I selected this case study, just to show the capacity of the technology. So this facility, this small industry consumes 30 cubic meters per day of fresh water for the industrial manufacturing process, generates approximately 10 cubic meters per day of wastewater. And what they do, they have a collection tank, and they pump out and truck out the wastewater to a wastewater treatment plant. This means that this process costs some money for the transportation, and of course, it has an environmental footprint. There are some greenhouse gas emissions related to this process. So the solution here that we seek was to reduce the cost for the overall wastewater management, and also to reduce the fresh-water consumption for the industrial processes. And this is why they decided to test a nature-based solution, so a constructed wetland. Of course, this is quite a unique application. So the first step would be to go to a pilot scale system to test, verify, and optimize a design for this particular application. And the second step will be to upscale then this design and build the full-scale system. So this was done. This was the simple collection tank that they had before. And after the small pilot that we built to verify and optimize the performance, we proceeded with the construction of the full-scale wetland facility. And as you can see in the picture, another advantage is the flexibility of the design of such systems. So we can design the system to fit within the shape and the available area and shape of the land available within the premises of the industry. So from that strategy of managing the effluent of the industry, we moved to this strategy. So the wastewater is treated now in the constructed wetland, while the effluent is recycled back to the manufacturing processes. So in this way, the small industry managed to reduce the freshwater consumption, while they reduced also the overall cost savings and the overall cost for the wastewater management, and eliminated the CO2 emissions for the need for transportation of the wastewater to a centralized facility. More case studies here about sludge dewatering. So this particular application to receive the water and dry sludge from municipal wastewater treatment plants. So these are some pilot beds that were built in Jordan to test again and optimize the design there. And currently, the full-scale sludge treatment wetland, as we call them, is under construction. Another system was designed in Oman for the 5-star resort. So what was the problem here? there was this 5-star resort, and they had an MBR, membrane bioreactor facility, to treat the wastewater from the resort facilities. But the sludge that was produced on a daily basis, they had to transport to a centralized facility that was located almost 80 kilometers away. You can imagine that this had a cost for the resort, and of course, these were related also to some to greenhouse gas emissions. So we installed a sludge treatment wetland to receive and dewater the sludge from the ADR unit. And take notice, as you can see here, that the wetland facility is located only 17 meters away from the pool and 70 meters away from the bungalows and the villas. And this is already running for 7-8 years, and there are no complaints for mosquitoes or smells developed in the area. I remind you, this is a hotel. This is a 5-star resort. So this proves, it's a very good case study that proves that if designed and built properly, we don't have any issues with smells or mosquitoes, which is usually the first or second questions that we get when we introduce this technology. And of course, the watering there is done without any chemicals and with only minimum amount for energy for a small pump that is used to pump the sludge to the bed. So how does it work, the sludge dewatering wetland? We have continuous sludge applications for a cycle that could go up to 8 or 9 years, depending on the sludge loading rate. So this is how the system will look just after fresh sludge is applied, and how the sludge is dried, and you can see the cracks that are formed on the surface, and specifically the ring that is created around the stems of the reeds. And this is how air is introduced in the sludge layer, and the hydraulic conductivity of the bed is maintained. And you can see an example after 8-9 years of this cycle operation. We have a nice layer of approximately 1 meter of a compost type, so digested sludge material built within the bed. So the brown color that you see here of the sludge indicates that this is an aerobic sludge. So we had aerobic processes in the system, in the bed. Why is this important? Because if we have aerobic processes, means we don't have any bad smells. So after we have this digested sludge build up, we remove this compost type material and we give it to farmers where it's used as a fertilizer in agricultural land. Another very interesting application is in the industry for oily produced water treatment. What is oil field produced water? From the oil and gas exploration and separation there is a produced water that is generated on a daily basis. So this residual wastewater from the oil and gas industry contains oil hydrocarbons, different fractions, heavy and light hydrocarbons, can be brackish or even saline. And of course, there are huge quantities produced on a daily basis. To give an idea, for every barrel of oil that is produced, we have 5 or up to 10 barrels of this oily wastewater generated. So you can imagine that we have millions of cubic meters of produced water generated globally from the oil and gas sector internationally. And this is why the water management often imposes a bottleneck on the management, on the pricing of the oil. So in this case, we are in Middle East, in the oil field, where the traditional disposal method is the so-called deep well injection. So in the oil industry, what they do with this water, they re-inject it back to the reservoir, which means that they will have to reintroduce and pump this wastewater to depths of 1.5 and 2 and more kilometers. So you can imagine the energy that is needed to send this water to these depths. And this picture shows only one facility with pumps, just one location with these deep well disposal pumps. So the goal here was to replace these disposal wells with a reliable and environmentally friendly alternative. So we used again the technology of constructed wetlands, and this is the system that was built, which currently is the largest constructed wetland system in the world, built in the world. So the area of this facility is almost 5 million square meters, so 500 hectares. And initially this facility was designed as a zero discharge, which means that downstream there are evaporation ponds and salt works to simply evaporate the water. So the treatment capacity of this facility is 175,000 cubic meters per day. To give you a better feeling of the size of this wetland system is equal to 1,200 football fields. So from this inflow of the oily produced water, we reach this outflow. And in fact, we grow fishes there, which is a very good indication, since fishes can survive, that this water has a limited toxicity. So what is the performance, the overall performance of this facility? The main goal here was to reduce the oil in water content in the water to the discharge limit, which was 0.5 ppm, so a very strict discharge standard for total petroleum hydrocarbons. And as you can see along the wetland length, in the outlet, we reach this very strict limit. So we have almost complete removal of the oil hydrocarbons there. But what is more fascinating here is the overall environmental performance of this facility. So we have energy savings compared to the previous solution for produced water management, the deep well disposal. So we have energy reduction, energy savings that exceeds 99%. So imagine we have 99% less energy used compared to the previous solution. And of course, this translates to 99% reduction of greenhouse gas emissions. And in fact, this facility alone contributes by 6% to the overall national target of the country of Oman to eliminate the emissions of the country according to Paris Agreement. And in this facility, it's a very good example how we can integrate the constructed wetland technology in a more circular and sustainable way of managing not only produced water, but also wastewater in general. So by replacing conventional technologies or deep well disposal, the first step would be to replace these previous management techniques with a constructed wetland. So by this, we have a treated effluent. So what we can do with this from just discharging to the environment? We can use it to produce aquaculture, okay, through research and development. For example, we can produce shrimps. We can use it for irrigation. So in this case, since the water is brackish, we can use it for biosaline agriculture. Biosaline agriculture is the agriculture where we irrigate crops or trees, plants that are salt tolerant, that can be irrigated with brackish or saline water. Or we can go to conventional desalination, so a reverse osmosis, which will be powered with the solar farm, so we have renewable energy, to go to more traditional agriculture like date palms in that area, or fodder grass, or simply vegetables and crops. So as you can see, the concept here is not just to reuse the treated effluent to just make the place look green, but to irrigate crops and plants and trees that have a market value. That is the concept, so that we can then generate an additional income and revenue, and stream of revenue for the stakeholders, for the company, and also more jobs for the local people. And furthermore, from the wetland, we have biomass, real biomass that is produced. So what we can do with this? We can use it to make compost, which then we can use in the agricultural field. So we close completely the loop. Or we can use it to produce biogas, which then is used to cover the small energy needs for the operation of the whole facility. So by doing this, we practically eliminate the CO2 emissions, the carbon footprint of the whole process there. And this means that we can generate carbon credits. So another income for whoever is the operator there. And this is already done. And of course, we conserve water, we save and protect freshwater resources, and we close the cycle of all materials, water, or biomass that are produced in this whole process of managing the wastewater. And this is an example of the facility where we have this irrigation field as a large-scale research. So we built 220,000 square meters of irrigation field where we tested different crops, different trees, saltwater and trees, irrigated with the treated effluent from that facility. So we had perennial species, annual species, and grasses. And to give you some ideas of the plants we tested, we irrigated cotton, several plants of biofuels, such as the resinous communities or plants, or simply maybe you know it as the castor oil plants, grasses that are used as fodder, and trees that will give a wood biomass, which could be used then in the market, or trees that are, for example, eucalyptus trees that are valuable for the cosmetic industry. And it is very interesting that from the biofuels that are produced in this way, we had 2 years ago the first commercial flight of Etihad Airways from Abu Dhabi to Amsterdam, where 50% of the fuel in that flight came from biofuels. So you can see the potential here that opens up, especially considering that the aviation industry is looking to invest in greening, in such greening options, because they want also to reduce the carbon footprint of their processes. So reusing treated effluents, and especially effluents that have been wastewater that has been treated naturally in an ecological system, is very attractive. And some nice environmental benefit and further ecosystem services. So by building a wetland, and in this case, this huge wetland in very hot and arid environment, this has attracted several birds and other wildlife. And there are more than 130 different bird species that have been detected in that area, where they find stopover during their migration between Asia and Africa. And another very nice example is how the wetland systems can also improve the microclimate here in the area. So by monitor the temperature and the humidity in the perimeter of the wetland facility, we found that there is a temperature reduction between the wetland body and the perimeter of up to 1 kilometer of the wetland boundaries. And this reduction is up to 10 degrees Celsius. So you can imagine in a warm environment how important this is for the people who are living nearby these such installations, such wetland systems. So to sum up, generally for the wetland systems for wastewater management, this green technology is a proven sustainable concept for the effective decontamination of different effluents. So we can treat domestic and municipal wastewater, but also different industrial effluents. The technology is proven even under the most harsh and difficult climates, such as the desert. It has a simple and non-technical operation and maintenance. It is cost effective, especially the operation could be up to 90%, the operational cost could be up to 90% reduced compared to a conventional technology. And the system can be designed with zero or minimum electricity consumption by exploiting the topography of the area. And of course, there is no use of any chemical compound. There are several environmental benefits. There is very small carbon footprint. In fact, the reeds act as a carbon storage, as a carbon sink. So we contribute to carbon mitigation and provide an increased resilience of the system. And there are further options to exploit the treated effluents, such as reuse in agriculture or recycle in an industrial process. And generally, the use of the nature-based solutions, such as constructed wetlands, is what we need for this transition that it's currently ongoing, a discussion that is currently ongoing to a circular economy also in the water sector. Of course, there are some challenges and some marks that always we need to keep in mind. We need to have a careful commissioning, so startup and plants establishment in the first months of operation, so that the plants can establish and grow gradually. We need to have an optimized management of the sludge wetland or wherever we have sludge mineralization beds. Skilled personnel is needed for the construction, so some experience is needed there. And of course, the design of such facilities should come from a person who has a long experience in the design of such systems, because as you imagine, although these facilities might look easy to design and build, just excavate some gravel material, plant the beds, plant the plants, but in fact, this is not so easy, not so simple to design. And unfortunately, there are many systems that were designed in the past by non-experts. These systems failed. They didn't reach any standards, failed to provide the services that were initially designed for. So just these are the remarks to keep in mind. And by this, I close my presentation, and I hope I covered most of your questions. Thank you very much.
Thank you so much, Dr. Alexandros, for giving nice presentation. And in this presentation, you have covered many things from basic to applied, and you have covered many industrial as well as domestic wastewater treatment processes. So we have received many questions from many areas from India as well as from abroad. So I think you have covered many questions in your presentation. So you have covered climate change related questions, their answers. You have covered agricultural, the questions related to agriculture, then GIS remote sensing related questions, and even the industrial applications. So you have covered many aspects, but 2-3 questions which are, I think, 2-3 questions, they are important. So I just ask you, that question is general question, but you will give the clarification on that particular question. So one of the question from environmental economics research student, he has asked the question, water hyacinth plants suggest the any possible ways to remove the plants to improve the water bodies. So this is one question. And career opportunity, if you highlight some, or if you give some ideas, what are the scopes or what are the opportunities after PG or UG or in the research point of view. So that will be better to know the students as well as the participants present over here. So these are the 2 questions. I think you have covered many questions. So just highlight, or you can give your opinion. Thank you.
Can you just repeat the first question, please?
First question is related to the environmental economics. How we will control the water hyacinth?
The water
plants. Water hyacinth plants.
Yes. I suppose they refer to plants that are invasive and usually you find in many water courses.
Yes.
Yes. So we did a study, actually, it was just published, where we used these plant species, water hyacinth, to see what is the phytoremediation potential of this plant. Because in many areas this plant is considered invasive, and to clean it, let's say, and maintain it from natural courses, from natural streams, it's often a headache. But on the other hand, these plants has a quite good phytoremediation capacity. So we use this plant in floating wetlands where we treated polluted water from a lake. So there was a lake, and this study took place in Egypt. So there was a lake which received a lot of pollutants load because there are many wastewater discharges to that lake, and the water there is heavily polluted. So we used a floating wetland with these plants to remediate the water from that lake, and it seemed proved to be very effective in removing organics, nutrients, and also heavy metals from the water. So it might be that you don't have just to remove and harvest, which is an intensive process, this plant, but find maybe alternative ways to exploit the capacity, the natural purification capacity of these plants in areas where it is needed.
Okay, thank you, sir. And one of question is related to the career opportunities. So if you give some career opportunities for this particular course, wetland or constructed wetland.
Generally, there are many careers opportunities. There are many research projects going on internationally. There are many research groups in many places around the world that are doing such research. I will say get connected. The easiest thing will be get connected to some groups or in Facebook, in LinkedIn, because such job opportunities for masters, even for PhD or postdoc, or even just job opportunities to work in wetland companies are posted quite often in this specific group. So that would be the easiest way for you and your students or whoever is interested to get in touch with the wetland world, let's say.
Okay, thank you so much, sir, for giving clarification, giving answers of those questions. So now over to presidential address. Now I request to our Vice Chancellor, Dr. Mrunalin Fadnavis, for giving presidential address.
Thank you, Durab sir. And I welcome Dr. Alexandros for this particular program which we have arranged for Wetland Day. So this 2nd February is really good thinking towards how to save wetlands and how to create or different awareness regarding the wetland issues. So thank you very much for giving such an enlightened talk because you have covered, I think, almost all the areas which is really needed. Let me just have some deliberations regarding how India is having this full of, indigenous sources for wetlands. And we have a lot of rivers, tanks in and around our villages and even in the near urban areas. And there are various indigenous ways which we have already developed from many, many years. Many architects, those who are working on the wetland areas or the, you can say the water management system, they used to say that India is the best architect or the designer source where from the you can say the old ages, they have constructed in such a way which is normally known as tanks. Means that is in our language we used to coin the word talav. So that is a tank, and the tank which has been constructed for just retaining the water, purification of the water, for agriculture, for many, many uses which has been supported rural population as well as the around population. It is a very important part which we have covered from many years, like 2000 years we were in that process. But unfortunately, because of a lot of population increase, like unprecedented use of plastics, not understanding the use of these particular things in a better way, we have lost some of this indigenous knowledge, we should say. But from your point of view, as you have given about the Europe and your area, I think we have tried to construct this from say like prior to British period, and that was the source for the water management or the source for potable water or everything which we can expect from the water system that was available in India. And very nice word you have coined for that, earth kidney. I like that, because that is really a thing which you have stressed upon, that particular word for this wetland day. What I will like to share, that to control the flood and the environmental system, what I can I was listening to your all part. I thought it's like a soak up process or holding water for various things which you have explained very well. So it's a giant sponges, I should say, which is protecting our economy, our earth, as well as the human cycles and human needs as well. So the vital job of recharging groundwater supply, that is also very important part from the thing which we need to understand. I think one question has been asked. Let me take first, and then I will add some few points in that. Because I heard that you are also in hurry, so I'll not take much time. But I just wanted to say that yes, there is a lot of scope for wetland development in the form of startups, as you have also in the last slide you have rightly mentioned. Because now we are looking of various type of startups in agriculture areas in such an ecosystem where most of the population, like say 50 to 55% of our population stays in agriculture system. So they can definitely go for such type of ideas which you have given, or we can have our own ideas which is depending upon our economy and our environment. So that can be a startup process, how to conserve this wetland areas in the different names which we are already having in our system. One research which I was involved in, one of the central part of the India, in that we have found that this particular wetland is giving good food chain for many people, as well as for like snake, birds, rabbits, and frogs. So that the food chain was so wonderfully taken care in the nature itself. So if we can protect them, cleaning of water, more potable water can be given, and the naturally occurring events will be there, and earth will also be saved, because that is also the part and parcel of all human being, that how to save the mother earth. So this is also the part where we are saving mother earth in the form of wetlands. So that is the most important part for human being survival, as well as for the other species on the earth. Similarly, about the nutrients, because when we see, I'm just talking about the tanks of India, lot of things which we are producing in that wetlands, that is related to the nutrients as well as. So we are producing such indigenous things, or the natural things which are growing in India and around. They are very important from the point of view of getting so many things naturally, which we need not to go to purchase a tablet outside in the in a shop. We can get many things from those species, and they are like organic in nature, and they will be highly useful, like scheduled tribes and related communities of India. They are already using such type of nutrients for their daily like food intake. So that is also the part and parcel of this wetland, or the quality of this wetland system. Then mangroves are also one of the things, because we have seen various development near urban areas where mangroves has been cut and big buildings has been constructed, but that is a problem creation for the balancing act between the nature and the human being. And therefore I think protection of mangroves, protection of such plants, protection of nutrients, protection of such type of areas which is very necessary to have a balance in the system is an important part from the point of view of understanding the economy of wetland system. So this is also why I says it is an economy, because we need to have, or we are in the system that we have to protect ecology from the point of view of our economic generation. And the political system, because I may be going little ahead of that, but political system should be so much robust, because they should protect our nature, not by just giving green signals to the various cement made construction, but to protect the ecosystem. So the ecological is political, but it should be in a good sense that I mean to say. And therefore, when we are talking about the capitalism, as you have also pointed about the circular economy, so I think capitalism and circular economy or some part is controversial many times. It is going on the one hand to ruining the thing, and on the other hand we are talking about the improvement of the nature. So we have to balance between these many things. Anyway, this is again a big topic about talking about the circular economy. But in 1980s and 1990s, when we are talking about reduce, reuse, and recycle, these are the three R's which we were using many times. I think it is very close with the economy of the wetland system, because if you want to protect these wetlands, we have to think what exactly consumer is behaving, how it is behaving in the form of using different type of things which is not good for the nature. So can we reduce, like plastic? It's a very normal example we give, like these things which is toxic, which is not or inorganic, which is not good for the health. So they should be reduced. So that is the first thing. Still we have to remember that reduce such things for the betterment of saving earth. Then reuse, can we reuse some things? We should not throw. Normally why I'm saying these are three, because all these waste we are using and throwing near the water system. So a water system is choking down, and therefore that need to be seen in a better way. And third is recycles. I think the recycle is the best thing in circular economy. All these three R's are very important, and therefore from this point of view we can say it shows that the designing of the protection of the wetland is nothing but how to enable a net positive effect on environment and the economy. There are many things are there, because these things are very close to our heart, and because of water we can survive, because of pure water we can have a good health and all that. Not only the human being but all the species on the earth. And therefore I think whatever the answers it has been expected by the students, they have asked general questions as well, like what is wetland from that point of view, how to go for jobs and how to use that particular thing or get awareness regarding the wetland. I think they must be satisfied because of whatever you have defined, whatever you have said. And as again I'm saying, in India we have all these type of potential, only we need to generate in a proper way. Last example I will give you, we have a very good paddy areas where because of this wetland this paddy can grow well. So there is a lot of things the economy can is sustained because of this paddy system, because that is full of water. We need to understand how the food chain ecosystem is connected through that, and out of that we have connected with various startups as well. So these startups are the part and parcel of wetland from many years. So all the people present over here, maybe according to their area, according to their system they can design, but for India as concern, or those who are having full of knowledge which is related to the water treatment part, they can get a very good idea, insights, input from what your lecture says, and we can also generate our own system which is based upon the sustainable development. So thank you very much, and I hope in this process we can definitely give a better chance to the students and researchers to go on thinking on such a day. It is a need of the day that we need to celebrate wetland days in the form of like this which we have done, because that type of cautiousness, awareness is always needed. So thank you again.
Thank you, madam. Thank you for your motivational and encouraging presidential speech or address. So I think everyone will get the motivation from your address. Now the end of the session, so that is vote of thanks. Now I'm giving the vote of thanks on behalf of School of Earth Sciences, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. I take this opportunity to propose a vote of thanks to those who have directly and indirectly contributed to this international webinar. We all are proud that today we have hosted this international webinar on wetland system. on the occasion of World Wetland Day 2021, and this event is listed and recorded in the World Wetland Portal website. This is global level world portal website, and there our program is listed. More than 1,650 participants from 23 countries participated in this webinar, and this is a huge success in itself. So at the outset, I express my heartfelt thanks to resource person Dr. Alexandros Stefankis. With short notice, Sir immediately accepted the invitation and gave us vital time from his busy schedule to grace this session. We are enlightened with your knowledge and virtual presence. Your research thoughts have enlightened our minds and shown us a new research path. Thank you so much, sir, for honoring the occasion and sharing research ideas and concepts today. I am thankful to the president of today's webinar, Honorable Vice Chancellor Dr. Mrunalini Fadnavis Madam, for her constant support and gave us a lot of encouragement and motivation. Thank you so much, ma'am. I would like to thank Honorable Pro Vice Chancellor, Director and Convener of today's webinar, Professor D.N. Mishra sir, for his overall support and needful guidance to organize this event. I would like to thank Honorable Registrar, Professor V.V. Ghute, Director, Finance and Account Office, C.A. Srenik Shah, Dean, Dr. V.L. Kadam, and all respected directors and heads of the various departments. I would like also thank to Solapur District Collector Office, Department of Higher Education and Environment Department, Government of Maharashtra for giving us an opportunity to organize this event at our university. A special thanks to the member of the organizing committee, teaching, non-teaching staff for their unflinching support and the coordination. Most important, our heartfelt thanks to all the participants from India and abroad for their active participation in this webinar. I also want to thank the people who work behind the scene to execute this event. Of course, our technical team, Dr. S.D. Raut and Professor C.G. Gardi. Thanks to both of you. I would like to express our sincere thanks to our Public Relation Officer and media person for giving excellent coverage in print and electronic media. With these warm words and a kind message, we move to the end of today's webinar. So thank you so much. One notice for all the participants for the e-certificate, please submit feedback form through given link or said link will be shared on your registered email. So with this, with the permission of the president of the function and the delegates, today's event is over. Thank you so much.
Thank you very much, Alexanders. It's very nice.
Thank you very much.
Thank you.
Whenever you will visit India, you please do come to our university.
Yes, I hope the whole situation will improve, that